Hello guys, good afternoon. You are welcome to my YouTube channel, the Explicit Tutorials. As you all know, my name is Dr. Joseph. Please, as you are watching this video, endeavor to subscribe, like, share, and comment. In today's video, we shall be discussing a topic in chemistry, and that topic is periodic table. What is the meaning of periodic table? Periodic table means a table that contains elements that are systematically arranged based on increase in atomic number, based on increase in atomic number. Periodic table is a table that contains elements that are arranged systematically based on what? Increase in atomic number. And this was stated by Henry Moseley. All right. However, Dmitry Mendeleev says that elements should be placed systematically in the periodic table based on what? Increase in atomic mass. This rule was first stated before Henry Moseley's own, all right? He was the first to state that elements should be arranged in the periodic table based on what? Increase in atomic mass. But Henry Moseley said that no, his postulation was wrong. He said that elements should be arranged in the periodic table based on what? Increase in atomic number. His postulation led to what is called modern periodic law. Modern periodic law. And this law states that the properties or the periodicity of an element is a function of its what? Atomic number. This law states that the properties or the periodicity of an element is a function of its what? Atomic number. Take note that electrons are responsible for the chemical properties of an element, while the neutrons are responsible for the physical properties of an element. Take note of that. To ask you, elements are systematically arranged in the periodic table based on which of the following? It is based on what? Increase in atomic number, and not based on increase in atomic mass. Take note of that. Now, elements that are found in the same position in the periodic table are called congeners, all right? Take note of that. And they have similar physical and chemical properties, all right? They have similar physical and chemical what? Properties, which means that they have the same outermost, they have the same valence electron on their outermost shell, all right? It could be cage shell or MN, as the case may be. If they have the same electrons in the outermost shell, that means that they are in the same position in the periodic table. Take note of that. It is very, very important. Also note that the vertical arrangement of elements in the periodic table is called group. The vertical arrangement of elements in the periodic table is called group, while the horizontal is called period. Take note of that. So let's check something out. Let me quickly use a diagram to explain it better, all right? Let me use a diagram to explain it better. One, two, three, four, five, six. Note that there are 7 periods in the periodic table. There are 7 periods and 18 groups altogether. 1, 2, 3, 4, 5, 6, 7. Okay. 1, 2, 3. I think it's going up, right? Okay, so let's go. Like this. One, two, three, four, five, six, 7, 8, 9, and 10. Though it's not straight enough, but it's how it should be drawn. One, two, three, four, five, six, 7, 8, 9, 10. Okay. One, two, three, 4, 5, 6. Nice. Hydrogen, helium, lithium, beryllium. 1, 2, 3, 4, 5, 6. It's going up. Let me take it down. 1, 2, 3, 4, 5, 6. All right. So what I have here is the full periodic table. All right. This you have 1, 2, 3, 4, 5, 6, 7. 7. This connotes the period. 7 like this. The horizontal arrangement, you call it what? Period. But the vertical is what? Group. Count. You have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Okay? Are you serious? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Where am I getting it wrong? 15, 16, 17, 18. Okay. Okay. Hydrogen, helium. Oh, is that correct? 1, 2, 3, 4. Hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorinium, sodium, magnesium, aluminum. Okay. That is, you have 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6. 1, 2, okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Correct. So that is, you have 1 to 7. This vertical arrangement is called group. Horizontal is what? Period. So what I have, the elements found in this very group are called, the first group, they are called alkaline metals, while the ones found in group 2 are called alkaline earth metals. Alkaline earth metals. But the elements found between group 2 and group 1, 2, 3, 4, 5, 6, 7, 8, or what? 0. The elements found between group 2 and group 3 are all called transition elements. I don't call them transition elements, I can also call them D-block elements. D-block elements. Alright, they are also called D-block elements. So, the elements found in group 7 are called halogens. Halogens, alright? Halogens. Because they have the ability to form salts, alright? And they are good oxidizing agents. The elements found in group 8 or 0 are called noble or inert or unreactive gases because they have octet or duplet state of what? Configuration. Okay. So what should we do now? Let's fill in the elements in the periodic table. I can stop at maybe element 30, alright? Hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chloride, argon, potassium, calcium, scandium, titanium, vanadium, scandium, titanium, vanadium, chromium, that is manganese. Okay, very clean. Very clean. Contains. Okay, scandium, titanium, vanadium, chromium, manganese, scandium, titanium, vanadium, chromium, manganese, iron, copper, nickel, copper, and what? Zinc, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Good. So hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chloride, or chlorine rather, argon, potassium, calcium, scandium, titanium, vanadium, chromium, manganese, many female, okay, something very clean, many female, good, it's correct now. Yeah, you have you now have germanium, arsenic, selenium, bromine, krypton. I think you have here neutron, okay, strontium, neutron. They have zirconium being the 40th element. All right. So for now I've been able to memorize 1 to 40. All right, because I'll not kill myself memorizing all the elements in the periodic table. So I have 1, 2, 3, 4, 5, 6. You have 40. Now you have scanned the elements found in this very region are called what? Transition elements or D-block elements, right? Now, what are I told you the vertical arrangement is called group, while horizontal, you call it what? Period. So what I've just done is giving us, okay, please take note that elements from cerium, which is 58, all right, to lutetium, which is 71, are called Latinide elements, or you can also call them Latinoid series. Then elements from thorium to lawrencium, which is 103, are called what? Actinide elements. All right. So cerium to lutetium, which is 71, they are called what? Latinoid series or Latinide elements. But elements from thorium, which is 90, to lawrencium, you call them what? Actinide. All right, actinide. So please take note of that. So that is all. That is what I just have to show you. Please, major concern right now is this guy, hydrogen. You know, hydrogen does not have a congener because it's just found only in group 1 all by himself. All right. So it is found in group 1. All right, and they will tell you which of the following is used to fill balloon. They'll give you helium. They'll give you hydrogen. Which will you pick? You pick hydrogen, right? Because it is denser than, it is lighter than helium. Is that not correct? Because hydrogen is 1, helium is what? 2. Please don't try that. Which of these is used to fill balloon? Please, it is helium, because helium does not support combustion, but hydrogen does. Hydrogen can undergo reactions, but helium is a noble gas. It cannot undergo a chemical reaction because it has a duplet state of what? Configuration. All right. So that is, and hydrogen has 2 oxidation states. It has +1 and it has what? -1. It has +1 and what? -1. Okay, let me rub off the board so I'll explain it better. So please take notes. I want to just illustrate it using diagrams for a better understanding. Our major concern right now is what? Hydrogen. Hydrogen has, you know, hydrogen is a diatomic element. All right. If I should pass electricity through this molecule, I'll have 2 atoms. All right. As soon as it undergoes dissociation, I'll have 2 atoms, because I'll have 2 atoms forming what? A molecule. All right. Which means that this guy is a diatomic element. Please, hydrogen has the ability to form numerous compounds. It has the ability to form numerous compounds. It can form HCl, HNO3, and so on and so forth. It can also form ammonia through Haber process, and I think it also contributes to what? Ammonium. All right, this ammonia and this what? Ammonium. So how do you think any of those can be what? Prepared? You know, if hydrogen gas should react with nitrogen gas, all right, what would you have? Ammonia. Please take notes. I told you guys that the deep lock elements are also called transition elements. Please, they are used as good catalysts and they have variable oxidation states. So during Haber process, which is used to manufacture ammonia, fairly divided ion is used as the catalyst. This equation is non-balanced. I'll put 2 here. I'll put 3 here. 6 hydrogen, 6 hydrogen, 2 nitrogen, 2 nitrogen. So you see, nitrogen has contributed to the formation of ammonia. If nitrogen 4 oxide should react with water, if NO2 should react with water, I will have what? HNO2 and HNO3. So I'll simply put 2 at the back of this place. So what do I have here? Now, nitrogen 4 oxide is called mixed acid anhydride because it reacts with water to form 2 acids. Because this compound lacks water, so it's called acid anhydride. It is a compound that lacks water. So when NO2 reacts with water, it forms HNO2 and HNO3. And this guy is called what? Aqua fortis. It is the most powerful oxidizing agent. It is very, very powerful. Okay, and it is produced through Oswald process. All right, Oswald process. Take notes of that. Take note of that. So nitrogen can form so many compounds, even KCl and what have you. There are numerous. But our major concern right now, you know that hydrogen can act as both metal and what? Non-metal. If I may ask you, what kind of bond exists in hydrogen chloride? Is it ionic bond or covalent bond? Please, it is what? Covalent bond. Most of us have always been taking it for ionic bond. It is covalent. No, normally, electrovalent or ionic bond is a type of bond that exists between a metallic and non-metallic what? Element, in which the metallic element gives out its valence electron to the non-metallic element to have a duplet or octet state of what? Configuration. Is that not correct? It is very, very correct. You know that hydrogen can also bond with fluorine. Hydrogen can behave as non-metals. You know that the group 7 elements are all called halogens and they have oxidation state as what? Minus what? 1. You see, so hydrogen has plus 1 and what? Minus 1. In hydride, it has minus 1. Please take note of that. The oxidation state of hydrogen in hydride is called what? Minus 1 and not plus 1. So how do you think it is prepared? What are the various processes that can be used to prepare hydrogen gas? It is very easy. It is produced when metals react with dilute sulfuric acid. If I should react sodium with H2SO4, which is a sulfuric acid, I'll have what? Na2SO4 plus what? H2. Sodium metal has reacted with sulfuric acid to produce what? Sodium sulfate and what? Hydrogen. Of course, it is what? Gas, and this guy is what? Salt. It is not balanced, right? I'll simply put 2 at the back of this place. If potassium should also react with this, I have K2SO4 plus H2, which is what? Gas. I'll put 2 at the back of this place. Same thing, if zinc should react with H2SO4, what will I be having? I'll have zinc sulfate and what? H2. The same thing, okay? It is very, very easy. Another way in which hydrogen can be prepared is when sodium is reacted with what? Water. You know, sodium is a good example of alkaline metal. It reacts with water to produce a soluble base and what? Hydrogen gas. It reacts with water to form a strong base which is soluble and what? Hydrogen gas. You can see that. Is the equation balanced? Yes, it is balanced. Yes, it is what? Balanced. Please, this is number 2. Hydrogen gas can also be prepared through what is it called? How do I put it? From water gas. All right. If carbon should react with steam, I'll have what? Carbon 2 oxide and what? Hydrogen gas. Hydrogen gas. So hydrogen gas. What I have here, you have carbon 2 oxide, right? And what? H2. This is called what? Water gas. You know, water gas is a combination of carbon 2 oxide and what? Hydrogen gas. Apart from that, if I should react methane with H2O, don't forget this guy is steam gas. If I should pass methane through water, I'll have CO and what? H2. Is it balanced? No, it is not what? Balanced. So what do we do in that case to balance the reaction? By placing number of moles. I have 6 hydrogen here, so I'll put 3 at the back of H. How many oxygen? 1. How many carbon? 1. So it means that the difference, this one is called synthetic gas. Alright? The difference between water gas and synthetic gas is that carbon 2 oxide is in ratio 1 to ratio 1 to what? Hydrogen gas. But in synthetic gas, carbon 2 oxide is in ratio 1, but hydrogen gas is in ratio what? 3. You see, that is the difference between water gas and what? Synthetic gas. Please take note of that. It is very, very important. Of course, producer gas is made up of CO and nitrogen. Yes, we know. That one is, yes, we know. We know. So please, another way of preparing nitrogen, some industries, they use nitrogen to convert vegetable oil into solid fat. In order to do that, do you know what they do? They react iron with water. They reacted iron with water. In doing that, iron, this you have. So this compound is a compound, isn't it? It is called triion tetraoxide. Alright, this compound is called triion because it has 3 atoms of what? Iron and 4 atoms of hydrogen. So it's called triion tetraoxide. Or I can also call it ion 2,3 oxide. Ion 2,3 oxide or triion tetraoxide. So is the equation balanced? I'll put 3 at the back of this place. Then I'll put 2 at the back of this place, then put 2 at the back of this place. So please, industries, during the conversion of vegetable oil into solid fat, they make use of what? Hydrogen, which is formed when iron is reacted with water. Triion tetraoxide or ion 2,3 oxide. So please, these are some of the ways in which hydrogen gas can be what? Prepared. Take note of that too. It is very, very important. Now we've established that already. So let's now discuss binary hydride. Binary hydride. Binary hydrides are compounds formed. Binary hydrides are compounds formed when hydrogen molecule combines with another element. Binary hydrides are compound formed, alright, when hydrogen molecule combines with another element. It could be a metal or what? A non-metal. In this case, okay, yes, I said binary oxides are compound formed when hydrogen molecules react with another element, which could be a metal or non-metals. We have 3 types of hydrides. We have ionic hydride. Now, this ionic hydride is formed when hydrogen gas combines with less electronegative elements. I recap. Ionic hydride is produced when hydrogen is linked or is joined to less electronegative elements like sodium. Okay, not sodium now. Should I use sodium? Okay, yes, I can use sodium. If sodium should react with hydrogen gas, I will have what? Sodium hydride. Is that not correct? Oh, sodium hydride. Then I think calcium can also react with hydrogen to produce what? Calcium hydride. Is that not correct? I think lithium can also react with hydrogen to produce lithium hydride. So, what do we do next? Okay, sorry. Okay, calcium is 2, and I have, okay, no. So what I have here are examples of what? Ionic hydrides. They are formed when less electronegative elements are reacted with what? Hydrogen gas. You have this. Now all these hydrides you have here, all these hydrides. So what do I have? Okay. I think I'll balance the reaction. I'll put 2 here. I'll put 2 at the back of sodium. So I'll put 2 at the back of this place. Put 2 here. Put 2 at the back of this place. Okay, is this balanced? Now, from what I have now, all these compounds, they are what? Hydrides. They are hydrides. These ones are hydrides. Please take note that hydrides, I said before that the oxidation states of hydrogen in hydrides is what? -1. My right hand way. The oxidation state of hydrogen in hydrides is what? -1. Take note of that. It is very, very important. Now, in this case, this hydrogen here is a strong brusted Lorry base. Is a strong brusted Lorry base, all right? Because it is acceptor. Look at, I have hydrogen plus water. This hydrogen here, all right, it accepts a proton donor from this place. It accepts a proton donated from this hydrogen molecule. If one proton is donated from this place, if I should add it to this, what will I have? H2. Is that not correct? I'll have H2 plus what? OH. I have H plus and OH minus. Normally this will go out. Now H will join this. I'll have what? H2. Then I'm left with what? I'm left with O. Then the remaining H here, it will combine with this. I'll have what? OH. So please, they'll ask you, they can bring this equation, they'll ask you, the hydride above shows which of these. Please, it is what? A brusted Lorry base. Brusted Lorry base, alright? Please take note of that. It is very, very important. Alright, from what I've given us now, we can also proceed. Now, so 1, 2, 3 are good examples of what? Ionic hydride. Alright, because they are formed when hydrogen molecule combines with less electronegative element. Please take note that ionic hydrides, alright, please, they are good reducing agents and they have high melting and boiling points. Take note that normally ionic compounds or electrovalent compounds, they have high melting points and high boiling points, and they are used as what? Strong reducing agents. Same thing here. Ionic hydrides, they have high melting points and high boiling points. All right, take note of that. Another type of hydride is what they call covalent hydride. Covalent hydride, all right? Covalent hydride is formed, all right? Is formed when hydrogen molecule combines with some metals, which could be what? Non-metals. Look at it here. If hydrogen, okay, how do I put it? Okay, good. Let me put it this way. Covalent hydrides are hydrides formed between compounds that have covalent bond. They have covalent bond. There are 2 types of covalent hydrides, all right? We have the hydrides that contain discrete units, such as CH4, NH3, NH4. You see, they have discrete what? Units. But there are some covalent hydrides that have large number, or they are polymers. For example, if I have B3, sorry, B2H6, I also have, which one again? Which one can I bring in? Aluminium hydride. All of these are examples of covalent hydrides. Water too is covalent, is that not correct? Hydrogen sulfide, hydrogen fluoride is covalent, right? Now, from what I have given us, all of these are covalent compounds. You see now that they combine with less reactive elements, Now, from what we've written, my major focus is this, and this. 1, 2, 3. So if I may ask you, which of them will become acidic when dissociated? Which of the following covalent hydride is acidic? Which of the following covalent hydride is acidic? Please, hydrogen fluoride is acidic because it can dissociate to have H plus and F minus. Water is also acidic because when it dissociates, you'll be having H plus and what? OH minus. So the both of them are both acidic. All right, please take note of that. It is very, very important. Number 3, of course, this compound, they have low melting point and low boiling point. The last one is what? Interstitial hydride. Interstitial hydrides. They are hydrides formed when hydrogen molecule is bonded with transition or D block elements, such as vanadium hydride, zirconium hydride, titanium hydride. All of these are interstitial hydrides. All right. Is there another one I've not given us? You have numerous hydride, numerous ones. Okay. You also have chromium hydride. All of these, so long the hydrogen molecule is bonded to a transition metal, you have what? An interstitial hydride. So that is what we have. In our next class, we'll be discussing the various types of oxides, which are basic oxides, acidic oxide. You can also have super oxide and also peroxide, you understand? So please, at this point, we'll call it a day. Please, thanks for watching. Do have a wonderful day. Please endeavor to subscribe.